7. Triangle ABC is shown. Just looking at the picture, what do I automatically know about it? It's isosceles, absolutely. And so my given, it is isosceles, and point D is the midpoint of AC. And we are trying to prove that BAC, so this angle is congruent to that angle, okay? And it gives you a proof. And all you have to do is come up with, actually, on this one, the reasons, and they give you a proof box. So, let's see what they have. We've got it, isosceles, D is the midpoint, that's a given. AD is congruent to DC by definition of midpoint, so that means this side is congruent to that side. Would you agree with that? Okay, and then it says BA is congruent to BC, so this side's congruent to that side because it's a definition of isosceles. Awesome. And then there's one that says BD exists. That means they drew that line there because you can draw a single line segment between 2 points. Do you agree with that? All right, and so now it's saying, hey, BD is congruent to BD. Why do we know that? What's the reason? What'd you say? Reflexive, absolutely. So this one you would drag up. Okay, so now it's saying triangle is congruent to triangle. What do we know about the triangles? That's the different packet. We did the practice tests in the thing back there. Yeah. We know side, we know another side, and we know a third side. So which theorem tells me I can say that? Side, side, side. And so I'm going to take that and I'm going to drag it up to there. So since I have two congruent triangles, then that means that I can say this angle is congruent to that angle because of what? Corresponding parts of congruent triangles are congruent, or as we called it, CP, CTC. Good? Make sense? Easy? See, that proof was easy. You guys can do this. All right, question number 8. There, I did that one. If I can find it. I grabbed out the, sorry about that. I grabbed out the wrong, where is it? Well, we're going to go through it and do it this way then. I'm not sure where my ones are. All right, that was 7. So, number 8. The proof shows opposite angles of a parallelogram are congruent. Here's my proof. ABC is a parallelogram with diagonal AC, and I'm trying to prove that BAD is congruent to DCB, so this whole thing congruent to that whole thing. All right, so I'm only looking for one reason on this one. So let's look at what are we doing here? What is happening in my statement? Addition, absolutely. And what are we adding? Angles. So therefore it has to be C for the angle addition postulate. Good? See? Easy peasy. All right, number 9. The diagram shows only the first step of constructing a line perpendicular to AB through point P. Which one? Is it A, B, C, or D? It is D because you got to set equal sides to put your compass at. Perfect. All right, last one. Okay, parallelogram shown. Point E is the midpoint and point F is the midpoint. What transformation carries the parallelogram onto itself? What's it mean by onto itself?
Like whatever you do to transform it goes back.
And exactly, it looks exactly the same, okay? So if we reflect across line segment AC, that would mean I have this line segment here, right? If I reflect it across that line, and it's going to be here, that point's going to be over there. Would you agree? Does that make sense? So it can't be that one. All right. If I reflect across EF, this was this distance away, so this would be this distance away. Is that going to work? Nope. Okay, rotation of 180 degrees clockwise about the origin. So if I'm going clockwise to 180 degrees, where am I going to end up over? If I am clockwise, won't I end up over here? Okay, so rotation clockwise about the center. That means if I rotate here, I'm just kind of rotating it around. So it has to be D. Does that make sense? Just take your time and look at each choice, and you guys are going to be rock stars. All right, good.